All right. Hello, everyone. Today we're going to cover 6.2 Part 1, which is composition of functions. And if you guys hear any bells, just apologize for that ahead of time. There's some passing period coming up. So composition of functions. Guys, this is another type of operation. It's not your typical arithmetic operation like adding, subtracting, multiplying, and dividing that we covered yesterday. So this will be new to you guys. Hopefully we get the hang of it pretty quick here. Our objective, of course, is to find the composition of functions. Okay. And guys, a little notation. So like yesterday, guys, we had f plus g of x, and that was our addition, right? That meant f of x. Back out of that. A little bit. F of x plus g of x, of course, okay? So, guys, for composition, there's a couple of different ways we can write a composition. This is just, guys, a note on notation, so you understand what it looks like. So composition, guys, the way I'm going to write it most today, we're going to say f of, like we say x, okay, but this is f of g of x. F of g of x is how we say that. Say f of g of x. That's how we pronounce composition. Okay, and another way to write it, the way the textbook does, they use this dot. So you could see that, f of g of x. So this one is going to be the more common notation I use today. That means we're going to compose the functions, okay? So we need to understand, what is a composition? Let's define this. Okay? In a composition of functions, the results of one function, guys, when we say results, we mean the range, or if we think x, y, the y values. Okay, the results of one function are used to evaluate a second function. So they're used to find when we say evaluate, they're used to find the range of the next one. Okay? We take these outputs and make them inputs, okay? And so what does this look like? So let me have an example here that kind of highlights what I mean. Example. So given, let's say f of x equals, I'm just going to list a function that has some ordered pairs here. 1, 8, 0, 13, 15, 11, and 14, 9. Okay, so given that function, and let's have a second function, g of x, and let's make these ordered pairs 8, 15, 5, 1, 10, 14, a little more squished here, and 9, 0. Okay, so given these two functions, let's do a composition. Let's find f of g of, I'm going to pick a specific value, f of g of 8. Okay, we're going to evaluate this composition. So, to do this, we want to find out what g, sorry, this parentheses, we need to find out what is g of 8. So, looking at the g function, we want to find the x value where it's 8. So 8 comma 15. G of 8 is 15. Okay, so that's what g of 8 is. What we're going to look for now is f of, well, we know g of 8 is 15, so we're going to find f of 15. So looking at the f function, the top function now, we're looking for f of 15. Where is the x value 15? Oh, right there at that ordered pair. So that range value is 11. Okay, so f of g of 8 is 11. We found these inside, we found g of 8 first. We plugged that in, and that gave us our 11. Okay, guys, we can work this the other direction. Okay, we can work this the other direction. Let's do another example. Let's find, kind of making this one up on the fly. So let's find g of f of 14. Let's find out what that is. So these are separate problems. I'll use maybe blue to highlight this one. So first thing we need to do, we need to find out what is f of 14. Okay, f of 14. So looking at the f function, the top function here, f of 14 is 9. 9. Okay, so now we're going to find g of 9. We're going to plug that into the g function. Okay, now looking at g, where is the x value 9? Oh, right there at that ordered pair. So g of 9 is 0. So g of f of 14 is 0. All right. Oh, sorry for the zoom, guys. Still getting used to the technology again, guys, so appreciate you guys being patient here. All right, let's maybe one more. Let's go f of g of 5. Let's find f of g of 5. So first thing we're looking for, g of 5. What is g of 5? Go to your g function, find where the x value is 5. It's at that ordered pair, 5, 1. Okay, now we're going to go and find f of 1. Okay, we took that and put that in there. F of 1 we're looking for now. Guys, f of 1 is 8. So f of g of 5 is 8. All right. So you guys should be able to, at this point, guys, we've done 3 of them, should be able to work these out a little bit here. So we'll have a handful of examples like this in our homework assignment. All right, let's continue. And let's look at a couple of linear functions. So guys, here we just had ordered pairs that we listed. On this next example, we're going to look at linear functions. Compose two linear functions. Okay, so let's look at an example like this. This is certainly different. So given, we're going to make f of x equal 2a minus 5. 2x minus 5, I apologize. And let's make g of x be 4x. Okay, so given this, we want to find f of g of x. Okay, and so note what we want to do. We want to substitute g of x into f function for x. Okay, so if you're looking at this f function, guys, you see where the x is. We're going to take what g of x is equal to, 4x, and we are going to substitute it in there. Okay, what that is going to look like, that's going to be f of g of x equals, well, what is the f function? 2 parentheses, we're substituting, we're using parentheses. What are we substituting for x? We're substituting 4x. We're substituting the g function in for x. And then minus 5. All right, we took the x out, plugged in what g of x was equal to, which was 4x. And now it's just to simplify, guys. 2 times 4, that's 8x minus 5. So our solution is 8x minus 5. All right. Guys, we can go the other direction. We can find g of f of x. What's that going to be? Okay, so in this example, let me go back to my given here. In this example, we're going to take the g function, and where there is an x, we're going to substitute in the f function. So it's going to look like g of f of x equals, well, what is the g function? It's 4 parentheses. We're taking out x and we're substituting 2x minus 5. A little bit of the distributive property. And we got 8x minus 20. Okay? So you can compose functions either direction, guys. Notice these aren't equal. Okay? Notice, okay, f of g of x is not equal to g of f of x. Okay. How do we say it? So order matters. Order matters. Okay, like when you're dividing or when you're subtracting, order matters when you're composing. Okay. And so I have one more example. Guys, sorry for the bell. Got one more example I want to do. This one's going to have a quadratic equation in it, so a quadratic function in it. So given f of x equals, quadratic x squared plus 2, and let's say g of x equals x minus 6. Let's find f of g of x. Okay, so you're again taking the f function. Okay, you're gonna take x out and you're gonna substitute in the g function. Okay, so this is gonna be f of g of x. So it was x squared. Well, we're taking x out, we're replacing it with the g function, x minus 6. So it was x squared plus 2. Well, now it's x minus 6 squared plus 2. So, guys, of course, with a quadratic, if you're going to square a binomial, you've got to FOIL x squared minus, writing it a little sloppy there, minus 6x plus 36. Got to bring down the plus 2. Simplify. X squared minus 12x plus 38. That is our f of g of x. That is our solution here. All right. And just for practice sake, let's find it the other direction. Let's find g of f of x. Okay, so starting with the g function, it's x minus 6. Okay, what are we substituting for x? So this one's going the other direction. This is taking the f function and plugging it in just for x. So x squared plus 2. Well, x squared plus 2 is minus 6 is x squared minus 4, just combining like terms. All right. So we've composed, we've gone both directions. We did it with ordered pairs, and now we've done it with linear and quadratic functions, okay? It's really all the examples I had for you guys. Have an assignment, so make sure we're knocking that out. Again, writing clearly, showing all work. Thanks for watching today, guys. Have a wonderful afternoon.